Everyone, I'm Pannaga Ravindra Hegde. In this video, I'll be demonstrating a simple and effective paper chromatography experiment. This technique helps us separate the different pigments present in the sketch pen colors. Chromatography is a separation technique used to separate components of a mixture. Thin layer chromatography and paper chromatography, they work on a similar basic principle. There is a stationary phase. In our case, it's going to be the filter paper, and a mobile phase, it's going to be solvent in our case, either water or vinegar. When the solvent moves up the paper, it carries the pigments with it. Each pigment moves at a different speed depending on solubility in the solvent, how strongly it sticks to the paper. Because of this, the colors separate into different bands. To quantify this separation, we calculate the RF value, which tells us how far a pigment traveled compared to the solvent. That we require 12 sketch pens, water and vinegar, paper cups or plastic cups, pencil or straw for hanging, scissors, glue and scale. First, I'm cutting the filter paper into thin equal width strips of around 24 strips for water and vinegar. Now I mark a baseline 1 to 1.5 centimeter from the bottom of each strip. I also mark a 0.7 centimeters above the baseline, assuming that this is going to be the solvent front limit. This is where I place the color dot. In the center of the baseline, I place a small dot of each sketch pen color, one color on one strip. I pour a small amount of solvent, water and vinegar around 0.5 centimeter height into each paper cup. Important thing to note is the solvent level should be below the baseline so the color does not dissolve directly into the solvent. As you can see, I have attached the strip to the pencil using a glue. Now let the strip hang freely. Place the pencil over the cup, ensuring the bottom of the strip just touches the solvent. The color dot must not touch the solvent directly, only the paper should absorb the solvent. As the solvent rises through the paper by capillary action, pigments begin to separate. Here you can see how it is separating. At this stage, for 12 colors in 2 different solvents, I have recorded the data. Before the results, a quick note on RF value. RF value is equal to distance traveled by the color divided by distance traveled by the solvent. It always lies between 0 and 1. Higher RF means the pigment is more soluble and moves faster. Lower RF means it sticks more to the paper. From the recorded data, colors generally traveled farther and faster in water than in vinegar. This shows water is a more effective mobile phase. Colors like yellow and sky blue moved the most, while black and dark green moved the least. RF values were consistently higher in water for almost all colors, proving that pigments have better solubility in water. Migration speed also followed the same trend. In conclusion, this demonstration or experiment clearly demonstrates that water separates pigments more effectively than vinegar. Each pigment behaves differently based on solubility and adsorption. And finally, paper chromatography is a simple and reliable method to visualize these differences. Thank you for watching.